Hey everyone, so here we are going to be looking at an SQL roadmap. Now, you might have seen loads of other roadmaps that are produced, but this is specifically important because regardless of what field you are in within data world, maybe it's data science, data engineering, data analytics, whatever it is, SQL becomes that really foundation piece that you can build all your skills off of. And whenever you're dealing with data, SQL is so much easier to manipulate data, transform data, and with new tools or popularity of tools like dbt and other tools built into BigQuery like Dataform, etc., SQL is going to be the tool which people use most often when doing transformation of data. And it's even more important when you're going for interviews, because at an interview, giving you an SQL problem to solve is much more easier than to test you on data ingestion or data storage, etc., which requires a lot of infrastructure work. Whereas with a SQL question, the interviewer or the company can really set things up in a short time and then test you on your skills within SQL. So we're going to be looking at a couple of things that would become the SQL roadmap that you need to go through in mastering the SQL. So here I have a few of the topics that we'll be walking through in SQL, and one of the key things that you also have to keep in mind is most of these things can be done by GPT or some of the other tools, AI tools that are coming up. So do you really want to learn SQL at this stage when you can leverage all these other tools? Well, the answer is yes and no, because using those tools can really speed up your data querying ability. But if you get stuck on a simple problem where you don't have a good foundation in how to go about debugging these things, then it's going to be a really, really hard problem for you, even if the simplest query is what you're after. So I always say use those tools like GPT and other things, which I'm a big proponent of, in speeding up your process rather than augmenting learning a new technology. So let's begin by looking at a few of these steps. So I've just minimized all the steps within my roadmap, and this is a very high level overview of what we are going to be walking through. So first we'll look at an introduction, and then what we call as data definition language and data manipulation language. Then comes a few of the key concepts within SQL like aggregate queries, joins, views, etc. And then we are going to be looking at a few of the popular functions like string functions, numeric date, conditions, transaction, and other things. And finally, we'll go on to looking at more advanced SQL stuff like subqueries and data querying techniques like window functions and stored procedures, etc., before ending with performance optimization. So here we have the introduction. So the first thing you want to understand when you're talking about SQL is what are even relational databases, because it's rarely a case where you're just dealing with one table. So you understand that it can really get complex when you're dealing with multiple tables and they have their own entity relationship diagrams that you need to understand and other things. So having a good grasp of what exactly is a relational database is going to be really, really key, because then you can easily walk through like one-to-one relationship or one-to-many or many-to-many, those kind of terms. You'll be able to understand really, really well. And this is going to really help you craft your query. So start with what are relational databases and non-relational databases, and what are the types of databases are there, and so on. And you also have to understand what are the limitations and benefits of relational database management system. So here, understand the pros and cons of this, and maybe in your company or in the project that you're working on, you might be using both SQL and NoSQL databases, or more recently, even vector databases. So having a good knowledge of all these types of databases is going to be really, really helpful. And here we have NoSQL versus SQL databases. Understand the difference. Of course, within SQL, you are dealing with relational tables, whereas with NoSQL, you're dealing with documents. So understand how beneficial they are and how disadvantageous they are in certain applications as well. Some of the keywords within SQL you have to understand, like the select, from, where, and all these things, which we'll come to in a bit. And then you also have to understand the data types that you're working with, because this is going to be another key. Are you working with strings or integers or date types or all these things? And then the operators is another key, where you're trying to filter on something if you want to look at and see if the columns are equal to some values, or if you want to do like an if-else condition, and so on. And finally, we have the statements as well. Basic SQL statements like select, insert, update, delete, and so on are other statements that you need to be familiar with as well. But these don't get used that often. If you're in the data analysis world, you'll probably be writing a lot of select statements, and you'll probably use a lot of these if you're building an application and where you have to do a lot of CRUD operation or create, read, update, delete kind of operations. So you'll probably be dealing with all these when you're doing application development. But regardless of that, you really want to get a good handle on the SQL statements. Next, you have something called as the data definition language. Now, even when you're coming across like free courses on YouTube or other places that you bought courses on SQL, always try to identify where each of these pieces fit in, and then it'll become really, really simple in doing that course and understanding where you're going. So within data definition language, we have truncate, alter, create, and drop, these kind of statements. Again, these will probably get used when you're doing more of application development, like you're creating tables, dropping tables, altering the schema of the tables, or maybe truncating and then overwriting some of the elements or rows within a table. So those kind of things are called as data definition language. Now, this is different to what we call as data manipulation language. So within data manipulation language, you have things like select statement, insert statement, update statement, and a deleting statement. So here you're retrieving data from a database with select, inserting, as the name suggests, you're inserting something, and update is modifying, and removing is by deleting certain rows. You can remove those from the database as well. So these are some of the basic query statements that you need to be familiar with, and this becomes the foundation data definition language and data manipulation language. And on top of this, if you have a good basic understanding of all the broader elements that make up SQL language, then it's really good. Now, just running a select statement on its own or selecting an entire database is not going to be useful. You'll probably want to do some data analysis. This is where aggregate queries come into picture. So you're able to do things like summation, count, average, minimum, and maximum, and so on. And there's plenty of more on aggregating queries. So you're basically doing a group by and performing some operation on the group of those rows of tables. So for example, if you wanted to count the number of transactions a customer has done within your e-commerce Shopify store, let's say, so you would get all the orders that customer had placed and then group only by that person or that customer and then do a count on the number of transactions. Or if you want to find out how much they've spent in your Shopify store, you can do a sum and then find out on how much they've spent in your store. So what I like to do always is when I'm thinking of all these aggregate queries, I like to just reference back to how I would do things within Excel or Google Sheet, because that is really, really beneficial. So always start with something very simple like a table. And if you're very, very beginner in SQL, then try to do things in Google Sheet before you move on to SQL, because Google Sheet is going to really help you with understanding the formulas, like how you go about doing summation and how you go about treating each of the customer and finding their number of transactions or amount of revenue they've contributed. So all these things are really helpful. So whenever I'm starting a new project, at least I used to start with just Google Sheets, importing data into Google Sheets and performing my analysis there, and then move on to writing queries in a data warehouse like BigQuery or Snowflake, etc. So if you're primarily focused on data analysis, start from there. If you're doing more of an application development, you'll probably want to start with writing simple CRUD API endpoints and then doing select, insert, delete, update, and all those statements. So now that we've looked at aggregate statements, let's look at another statement, which is joins. So join queries are another piece of SQL puzzle, which is really, really important to understand how they work. And there are many join types. There are only a few types like what we are going to see next. But this is really helpful when you're especially working with relational databases. And like what I said in the introduction part, usually when designers build a data model for the kind of data they're about to store in the database, they'll usually have some sort of entity relationship diagram where they're storing data in separate tables just to normalize them. And if you go in trying to build a data analysis or a dashboard in that team, then you'll probably want to join back all these things to get to the final table that you're interested in. And that is where join queries come in. A simple example is, imagine you have a Shopify store again, and you have a list of all the customers in one table, and then a list of all the orders that all the customers have placed in another table called as order table. And maybe there's another table called as product tables, which list only the products that you have in your Shopify store. So in these cases, what you probably want to do is join at least 2 or 3 of these tables to get to a final analysis, like what were the top selling products in the store, or what were the highest revenue generating days in your store. So to do analysis like this, you have to join multiple tables, and that is where joining or queries on joining is going to be really helpful. So the first one is inner join, where you're combining 2 or more tables based on a related column. There is also left join, right join, outer join, and self join, and cross join as well. So here's a simple table that I've found, and this is where we have left join, where you retain all the values from the A table, and then you only retain the values in the B table that were able to match with the values in the A table. So that is left join. The opposite is right join. This rarely gets used, but most often you can write a right join in a way that it can become like a left join. And then there is full outer join, where you're comparing both these 2 tables and then bringing in all the rows from either table. So if a row in A hasn't matched with anything in the B, then it'll just come up with null rows or null columns. And then same again, if some rows in B are not able to match with any of the data in A, then you'll have some null rows. But essentially, you'll have all the data that you have in both the tables in this full outer join. Next, there is also inner join, where you only get what were matched in both the tables. So if there's a row in A and then if there's a row in B and both of them match on a parameter that you find or a condition you find, then it comes in the inner join. If a row exists in A but then not in B, then that gets discarded. So those are some of the top kind of joins that you probably will use most often. There's also cross join and other things, but you don't have to worry about that at this moment. So next we have some data constraints. Let's look at what we have in here. So within data constraints, so this is how you would probably build a data model, or if someone else has built a data model in your team, this is how they would have designed it. There's always a primary key like an ID or something. Then there is a foreign key. So imagine this was table A and this was table B. Then you have a primary key in here, which is an ID, and then this references some of the field within this table. So this would be a foreign key, right? So again, all these concepts will become much more clear once you work on a solid example. But to just give you an idea, so there are primary keys and foreign keys that you have to understand. Then there are uniques, not nulls, and checks as well, which are some of the constraints that you can put. So with unique, you can ensure only the values in the column are all unique. And this is specific to the databases as well. So some databases support a lot more than just these. Then there is also not null, where you're ensuring a column cannot have any null values. And if it does come up with null values, then it just gets rejected. We'll also look at indexes and views first. So when you're working with a database or a data warehouse, there are these concepts called as views and tables. So usually think of a table as anything like a Google Sheet. So you have one Google Sheet, think of that as a database. And within that, you probably have loads of other sheets like Sheet 1, Sheet 2. Those can be your tables. And then there are these views which are built on top of the tables, where you put in your SQL query. Instead of running and storing that as a separate table, you just save that as a view. And whenever you query this view, it actually runs the SQL behind it and it gives you the result. So think of this view as something that does not have data, but actually has your SQL query that you're saving. And there's more to it than just that. There's also materialized view and other things, but understand there are views and tables in your database. So here you need to be understanding how to create a view, modify view, and how to drop a view and recreate them and so on. Then we come to what are called as indexes. So we'll come to more advanced ways of optimizing your database. You always have to have a way of optimizing the queries that you're running. So maybe the database you're working with is more read heavy, or you're doing a lot of queries. Maybe there are other instances where you're writing a lot of data than querying data. So in those times, you need to understand what are indexes, how you can optimize your database for the best query result, because the last thing you want is to query a database and then it takes like 10 minutes to give you back the results. So if you have indexes and other things properly set up in place, it's going to be really, really fast to run that same query within a few seconds. So here you need to understand what are managing indexes and what can be query optimization. So next we'll move on to few of the functions that we have within SQL. So again, these are no way just the exhaustive list. There are way more functions than we can fit in this block over here, but I would advise you go into the actual reference documentation for the database that you're working with and then find all these things there. But the most popular ones that get used again and again are these. So there are combining strings. So let's say you have a field with first name, and then you have another field with last name, and you want to combine them to get the full name. So that's when you would use concatenation. There are substrings, replace. If you want to find a length of a string, you can do that. There's uppercase, where you can change the case of your field to all uppercase or all lowercase, and there are many other functions there. Similarly, we have numeric datetime functions and conditional functions as well. So within numeric functions, there are functions like floor, which is going to round down your number. So imagine you have a decimal number which is got loads of decimal points, and then you want to round it down. You do this. Ceiling is just rounding up, so 5.6 becomes 6 instead of keeping it as a decimal number. Then there is rounding up, where you reduce the number of decimal points. So if you have like a number which has got like 10 decimal numbers in it, you can just round it down to 2. Then there is absolute, and then mod, and so on, where you get the remainder in division, etc. There are also datetime functions, where you can convert a string to a date or a time, or you can just extract the date part. So if you want to extract the month from a date, you can do that. There's a date difference, where you can give 2 dates and then get a difference between them. Like you've wanted to find the number of days between a purchase and a refund, if you will. So those kind of things can happen here. Then there is timestamp, where you can get the date and time that are stored in your database. There are also conditional functions like if, else, and so on, which you might be familiar with if you've done any other programming. So here we have the case statement, which is similar to if, else, and there is null if, so returning null if 2 expressions are equal. Then there is coalesce, returning the first non-null value. So these are all good when you want to have a clean query where you're not just returning null values, you can return like 0 instead of null. Then we have what are called as transactions. So transactions are really helpful when you think about transaction database. So there are basically 2 types, OLAP and OLTP, which are analytical processing and transaction processing. When you're looking at transaction processing, these is used when you want to do a series of steps and you don't want to fail on any one of those. So for example, if you are going to build an application where when a customer presses on a buy button, there has to be a lot of things that has to happen. So it has to go and update the inventory table or reduce the amount of inventory that the customer has purchased. And then it has to update the order table, and it also has to go and debit or credit the amount from the bank and then update payment table. So there's a lot of things that it has to do when you press on that buy button. So you can put all of that into what we call as a transaction. So if all of them passes, then you go ahead and get the customer to the next page or the confirmation page. But if either one of them fail, then you just revert everything back. So for example, if this customer pressed on the buy button and you realize you're out of inventory, then you fail that transaction and don't go and do the payment and order table update, etc. So this is very, very important, especially when you're building applications. So here we have transaction statements like begin, commit, callback, ACID transaction, save point, transaction isolation levels, and so on. So if you're especially building some applications, so these concepts are going to be key there. Next, we have some advanced SQL functions like scalar and column. There's row and table as well. So here you're returning a single value. So you can have like a subquery which returns a value and becomes scalar. You're returning the entire column of values or the entire row of values, and you're returning a table of values here. So these are some of the advanced query functions. So here I mentioned about subqueries. So let's look at what subqueries are. So subqueries are when you want to use a result of one query and then build more analysis on top of that. So you would write one single query, and then outside of it, you write another query, and outside of it, you can write another query. So those are called as subqueries. So imagine this is my single subquery, which I'm using, and then on top of this I can write another query just on this. So instead of saving all this into a table or a view, I just write a SQL that gives me this value, and then I can write on top of it. So those are types of subqueries. So there are nested subqueries, there are correlated, there are various different types of queries. There's also common table expression which you could use, and so on as well. Next, when we come to data integrity and security, we have few constraints, like you can grant and revoke access to certain tables, to certain team members, or if you are working with outside vendors, you can grant them access so that they're able to maybe read data but not write into it. Or you want to ensure that new team members don't delete data in your database. So in that case, you can have access controls there. So there are some good data integrity and security features that you need to work with when you're working with any type of database or data warehouse. Finally, we also have query optimization techniques like we spoke about. There are like using indexes that are optimizing joins, reducing subqueries, selective projections. And if you're working with data warehouse, there might be clustering and partitioning, and all these things really help you with query optimization. So it really depends on what kind of data you're storing and what kind of queries you're performing. Is your database just a read-heavy database or a write-heavy database, and so on? So you really have to understand what query optimization techniques can be used. Next, there are also query analysis techniques. So when you're optimizing, you can actually query the database to explain what exact steps it is taking to run your query. And when you do an analysis on what's happening, then you can try to optimize each of those parts. Then there are even more advanced SQL concepts like recursive queries and pivot and unpivot operations, window functions, which are really, really beneficial. So imagine window functions are like grouping by rows, whereas the regular group by functions are like grouping by columns. So this is a simple way of understanding these, but then there are of course other nuances to understand here. Then there are common table expressions, which are like temporary tables that you can create similar to subqueries, but you actually give them a name and then they have a temporal result that you can work with. Then there are also stored procedures and functions, and with some of the modern data warehouses, you can even write Python functions or Spark functions that your function to execute a SQL query. So these are like encapsulating complex SQL logic. You can have simple procedures as well, which run on a schedule, so you don't have to run them manually. So imagine there's a report that you have to produce every day. You don't have to run that every day. You can just put that in a function or a procedure that does the cron job. Then finally, we also have performance optimization, because all the work that you're doing, it's of very less use if people are not able to use it. So that's where you need to have performance optimization so that not only you, but the other team members or the customers are able to use your SQL. So that's an overview of a roadmap that you need to work with when you're trying to learn SQL. Again, there are all these tools, AI, GPT, Copilot, and other tools which are able to do most of these. But if you're building an application and designing something and building a data model, having a good grasp on what all these things mean, like for example, OLAP versus OLTP, transactions and optimization. So these are some things that you can get input from a GPT, but you still have to have a fundamental knowledge of all these things before using any of that output. So hopefully this was helpful in your journey towards learning SQL.